Next up, we look at logarithmic equations and inequalities. First off, we start with logarithmic equations. And we've already discussed that you can't take a log of a negative number, so it has to be positive. And the base also has to be positive and not equal to 1. Which means it's very important to check each answer we get, whether it's valid or not, the part of the positive and the negative. So we can start with this right here. Here we have 2 log base 8 of x plus 2 is equal to log base 8 of 2x plus 19. Here we can rewrite this where we take the 2, because of the power law we can use it as a power, so we have x plus 2 squared log base 8 of that is equal to log base 8 of 2x plus 19. And if you see this right here, we are just comparing x plus 2 squared to 2x plus 19. So x plus 2 squared equals to x plus 19, which is just x squared plus 4x plus 4 equals to 2x plus 19, which gives us x squared plus 2x minus 15 equals 0. Then we can solve this and we get x1 to be 3 and x2 to be negative 5. So here we have to check if each of these values, does it go with the conditions that we need. So we'll substitute our x's into these and check if we are taking a log of a positive value. And if we try 3, we are taking the log of 3 plus 2, which is just 5. So that's okay, because it's positive. And on this side, if we put 3 in here, we get 2 times 3, which is 6, plus 19, which is 25, which is again positive, so it's okay. When we use negative 5, if we put negative 5 here, negative 5 plus 2 is negative 3, and we can't take log of a negative number, which nullifies that option. Yes, we can put negative 5 here and we get a valid positive value, but one of the sides is not valid, and so negative 5 will not be an answer. The only answer will be 3. The only answer will be 3. Next up, we have this right here, where we have base x, and we need to find what that base x is. So firstly, we can rewrite all this, and we get log x of 2 power 4 minus log x of 4. 2 power 4 is just 16. And then remember, we are subtracting 2 logs, so that therefore we are using the division law. So we have log x of 16 over 4, and we want that to equal to 2. This rewriting this will give us x power 2, right? Because this goes up superscript, this from subscript goes to a normal number, will equal to the answer that you have applied the log to. 16 divided by 4 is just 4. Then x squared equals 4. We have either x equals positive 2 and x equals negative 2. And from this, negative 2 is not possible because we are using x as the base. And for the base, we definitely require it to be positive. Therefore, the only answer will be x equals positive 2. Next, exponential equations. In IGCSE, we did learn how to solve exponential equations where we could convert them into the same base. Now, we will find how to solve them when terms cannot be converted into the same base, right? And we do that using our logs. So here, if you get a question like this, you apply log on both sides. The general thing is you just apply the normal log that we have, log with base 10. And if you apply it to both sides, then we get log base 10 of 5 power 2x plus 1. And that will equal to log base 10 of 7. Then remember, the power can go at the front due to the power law. So we end up getting 2x plus 1 multiplied by log base 10 of 5 equals to log base 10 of 7. Then we can divide each side by log base 10 of 5, divide by log base 10 of 5, and we end up getting 2x plus 1 equals log base 10 of 7 divided by log base 10 of 5, which is just 1.209061955. Then we subtract 1 to that, we get 2x equals to 0.209061955. Divide by 2 on both sides, we get that x is equal to, into this significant figure, 0.105. And that's what our x will be. Second one, same thing. Apply logs to both sides. Normal log base 10. We end up getting log base 10 of 3 power 2x equals to log base 10 of 4 power x plus 5. And then we can take our power at the front for both. And we get 2x log of 3. I'm removing the base 10 because that's the normal. And if you write just log, it implies that it's base 10 equals to x plus 5 log of 4. And then here what we can do is divide by x plus 5, divide by x plus 5, and then we can divide by log 3 as well on both sides. We end up getting 2x over x plus 5 equals to log 4 over log 3. And solving this equation, obviously you can find the value of log 4 over log 3. Solving this will give us x equals to, into three significant figures, 8.55. That's going to be our value of x for B. Next, another exponential equation where we want to solve this, again correct to three significant figures. So we have 2 times 3 power 2x plus 7 times 3 power x equals 15. Here what you could do first is factorize your 3 power x. So we factorize 3 power x, we end up getting 2 times 3 power x, because 3 power x times 3 power x, you just add the powers, you get 2x, plus 7, and that will be equal to 15. In this one, we need to use information that we learned for pure 1, where again, if you look at this carefully, and if I rewrite this, you will get to know what I'm planning to do. So you have 2 times 3 power x power 2. This is possible. Why? Because this just means I'm multiplying the 2 and the x, I'll get 2x, plus 7 times 3 power x equals 15. And if you notice here, you have something power 2 and something power 1, where 2 is 2 times the value of 1, which tells you that you can do a substitution here. Suppose we let y equals to 3 power x. We end up getting 2y squared plus 7y equals 15. And we can solve this equation right here. So 2y squared plus 7y minus 15. We get that 2y minus 3 and y plus 5. And from that we get that y equals to 1.5 or y equals to negative 5. Then we're going to try each one. So 3 power x equals to 1.5 and 3 power x equals to negative 5. This is not possible because this, if you rewrite it, remember this is the base, this is the exponent, and this is the answer. We can write it as log base x of negative 5 equals to 3, which is not possible because we can't take a log of a negative number. This is going to be invalid. We can do this instead, where we can do the same thing again, where we can find 3 power x equals to 1.5, apply log on both sides. You end up getting x log 3 equals to log of 1.5, and then you can divide by log 3 on both sides, and we end up getting x is equal to 0.369 into three significant figures. Remember, again here we applied the normal log, which is log of base 10. Next up, let's look at exponential inequalities. So we all know that an equality symbol is reversed when you divide by a negative value. For example, if we have negative 2x is greater than 2, and if you divide by negative 2 and negative 2, we get that x is less than now. So this flips negative 1. Why? Because we divided by a negative value. Now let's look at the log values, okay? So in a logarithm, and I'm looking at log base a of y equals x, yeah, which comes from a power x equals y. So here, if your answer, which is y in this case, is greater or equal to 1, then your exponent, which is your x, is always greater or equal to 0. If your answer, however, remember answer has to be positive anyways, so if your answer is positive, so greater than 0, but it's less than 1, so it's between 0 and 1, then your exponent, your x, will be less than 0, so it will be negative. Remember, your exponent can be negative, right? And you can see this with an example right here, where anything below 1 as your answer will give you a negative exponent. And you should realize that if you divide by any log of a value that is less than 1, then you will need to reverse your inequality sign. Now let's look at this example right here. 0.6 power x is less than 0.7. And the way you would solve this normally is using logs, right? So log 0.6 power x less than log of 0.7. Rewriting this will give us x log of 0.6 less than log of 0.7. And then you want to divide by log of 0.6. Now 0.6 is between 0 and 1. Therefore, you are dividing by a negative number. So if you divide by log of 0.6, and here as well divide by log of 0.6, you will need to reverse this inequality sign because log of 0.6 is negative and you're dividing by a negative number. So it ends up becoming greater than. On the left side, these cancel out, you end up with x. On the right side, you have log of 0.7 divided by log of 0.6, which is, into three significant figures, is going to be 0.698. But they told us to give our answer in terms of the base 10 logs. Therefore, we're just going to remain with x is greater than log base 10 of 0.7 over log base 10 of 0.6. That's going to be our answer. Next up, we're told to solve this. So 4 times 3 power 2x minus 1 greater than 5. And we want to give our answer in terms of base 10 logs only, right? And so with this, we're going to start off with dividing by 4 on both sides to isolate the exponent term. So we end up getting 3 power 2x minus 1 greater than 5 over 4. Then we can apply logs on both sides. So log 3 power 2x minus 1 greater than log of 5 over 4. Then what we can do here is obviously take the power onto the front using the power law. So 2x minus 1 log 3 greater than log of 5 over 4. And this, I'm going to expand this right here. The reason why is because we want our answers to be in terms of base 10 logarithms. So we have to write everything in terms of logs, right? So we're going to have 2x log 3 minus log 3 greater than log of 5 over 4. Here we can take this log 3 to the other side. And here even we can take one of the terms and put it at the top here as the power of 3. We end up getting x log 3 squared greater than log 5 over 4 plus log 3. I'm going to simplify this right here because remember, if you're adding two logs with the same base, remember both of these are base 10, then we can just multiply those things together. So we end up getting x log 9 greater than log of 5 over 4 times 3, which is going to be 15 over 4. And then you can just divide by log 9 on both sides. We get that x is greater than log of 15 over 4 divided by log of 9. Next, we are told to solve these inequalities into three significant figures. So we learn how to do modulus, where a modulus just means that we can either have a negative or a positive. So for here, either 4 power x minus 8 equals 2 or 4 power x minus 8 equals negative 2. And so we have either 4 power x equals 10 or 4 power x equals 6. Then with both of these we can do our logs. So here we get x log 4 equals log of 10. Remember, we have applied base 10 to both of them. That's the normal way of applying logs. And here we also have x log 4 equals to log 6. Remember, log of 10 base 10 is just 1. So we're going to write this as 1. And so we end up having x equals to 1 over log 4. And on the other side, we have x equals to log 6 over log 4. So we have two possibilities for x. The first one being 1 over log 4, which in these significant figures is 1.66. And the second one being log 6 over log 4, which in three significant figures is 1.29. So these are going to be the two values of x that are coming from this thing right here. Next up, we look at b. And this is similar to something we did previously. where you have 3 power 2 modulus of x equals to 6 times 3 power modulus of x plus 16. And I rewrite this, I can get 3 power modulus of x power 2 equals to 6 3 power modulus of x plus 16. And what you see here is a case of converting it into a quadratic. So we can let y equals to 3 power the modulus of x, and we end up writing y squared equals to 6y plus 16. Rewriting this will give us y squared minus 6y minus 16 equals 0. And we can solve this right here. And rewriting this will give us y minus 8, y plus 2 equals 0, which tells us that y is equal to 8 or y equals to negative 2. But remember, y was what? Y was 3 power the modulus of x. So 3 power the modulus of x is equal to 8. And solving this, you have to apply log on both sides. So we have modulus of x log 3 equals to log of 8 over log 3 over log 3. Cancel, cancel. We get that the modulus of x is equal to 1.89 into 3 significant figures, which just tells us that x can either be positive 1.89 or x can be negative 1.89 because of the modulus sign. That's when y equals to 8. Y equals to negative 2 is an impossible scenario because you can't have 3 power x equaling to a negative number, because again, if you change this into logarithmic form, we end up getting log base 3 of negative 2 equals to modulus of x, which is impossible because we can't take log of a negative number. So your only two answers will be 1.89 and negative 1.89. And that is it for this lesson.